Hello students. All right, on this episode of Mathematics, I'm going to talk about our foldable. I'm going to have to move around the page a little bit just because of the fact that it's not in order when I printed. This is just working directly from the PDF. We're specifically, of course, going to be talking about literal equations. Now, this top equation where it says recall, solve for x, and bear with me, my cat is bothering me, so he's, of course, one of the whole reasons that this series is called Mathematics, because my cat will not leave me alone, and he's now walking all over my iPad. That's neither here nor here. All right, so I want to isolate or solve for x, my variable right there. Now, I'm going to use my inverse operation to get rid of one of my two terms, either the x or the 7. Honestly, I mean, I can work with any term, but the idea is that I want to get all of my variables on one side and all of my constants on the other. I have one variable and one constant on the left and a single constant term in my right expression. So I'm going to go for the constant, so on the left with the variable. So I'm going to subtract, let me go a little bit smaller on my pen here. It's a little bit too big for the size I'm working. Okay, I'm going to subtract 7 from both sides. This is going to give me x is equal to negative 12 minus 7 gives us negative 19. Okay, that seems pretty simple, right? We're going to use the same concepts for problem number 1. Let's look at problem number 1. It tells us to solve for a. So I'm going to highlight the variable that I want. And an easy way to deal with this and handle this is to treat your variable that you're not looking for, treat them as a constant. Just treat them as constants that you can't combine. Like, I mean, in reality, if we look up here, let's look up here, okay? When I subtract 7, I'm really subtracting 7 like this. 7 plus x plus 7, and I'm subtracting 7 from both sides. I mean, this is a way that I can look at this as well. The 7's cancel. They're on the same expression, so x is equal to negative 12 minus 7 will give us negative 19. So now I can combine, and we can make our equation look like this and solve it that way too. We're going to do the same thing. I want to get rid of that b, so I'm going to subtract b from both sides. Remember, that's plus, so that's going to be negative b plus a plus b, c minus b. Okay, now we're going to rewrite our equation because the b's cancel each other out there. That becomes a 0 pair, so a is equal to c minus b. Or we can do this the old way that we did this. Either way makes it simple. Whichever way works for you, please do so. So I'm going to subtract b from both sides, cancel that out. That's going to leave me with a is equal to c minus b, because I can't combine those two. So that's just going to leave me with c minus b, because I don't know what c equals and I don't know what b equals. And I want to preface this, or I can write this, a is equal to negative b plus c. The biggest, most important thing to note, stop cat, is that your terms, that coefficient, that negative 1 or positive, this negative or positive belongs to that term. Okay, so we need to keep that there. So now let's go over and look at the second recall. All right, solve for y. Well, just like before, all right, we're going to add 9. We're going to inverse of negative 9 is positive 9. We're going to add it to both sides. That's going to give us y is equal to 34 plus 9 is 43. Not too bad, right? We're going to do the same thing for our actual literal equation, because the top one, this equation up here is not a literal equation. In order for it to be a literal equation, we must have 2 or more variables, okay? So now I'm going to go and look at this, and I'm going to solve for d, which is that one there. So now I'm going to do the inverse operation of the variable. So I'm going to add e, so then that's going to give me d is equal to f plus e. Not too bad, right? It's simple. Very straightforward. Now, let's look at the next problem. Problem number 3 and 4. Here it gets a little bit more challenging, but honestly, not really. Okay, what's happening here in the first one, recall? Negative 6x is equal to negative 30. Now remember, this negative 6x, they're multiplying. So the inverse operation of multiplication, I want to look at what's going to make that coefficient with x, or that number with x, 1. I'm going to divide it by -6. So I'm going to divide both sides by -6. That's going to give me x is equal to 5. All right, let's look at number 3. It's the same process. We want to solve for r. And now I can look at that 2 pi r. This is the same thing as saying 2 times pi times r. Now the commutative and the associative property under multiplication says that I can order these and group these in any way that I want. So I can say 2 pi and group times r. I can say 2 times pi r. I can also say 2r times pi if I wanted to, for some reason, isolate by pi, which normally you're not going to do that. I mean, just realistically, you're going to be solving for the variable, okay? So I'm going to go ahead and rewrite my literal equation here. Okay, I'm going to rewrite this as c is equal to 2 pi, and I'm going to group those two, times r. Well, just like we did up here with this one, this equation up here, we want to divide by the coefficient with r. The coefficient with r is 2 pi. So we're going to divide each side by 2 pi. The 2 pi's there cancel out. And so r is going to be equal to c over 2 pi. Now, if you notice, I switched. The r is not on the right side. The r is on my left side. I can say this either way. I can keep the same order. So that's c over 2 pi is equal to r. Both are correct ways to talk about that. See, it's not that bad. We have solved for r. We know that we're done because we have solved that variable that it was asking for us for is by itself. Okay? Now, problem number 4. Let's talk about the recall. Okay? In order for us to solve for y, I'm going to multiply both sides by the denominator in our fraction. So I'm going to multiply by -4. So that's going to give me y is equal to, that becomes 1. Y is equal to -32. All right, we multiplied by the denominator. I have a fraction. I have a denominator. My denominator is 4. So that means I'm going to multiply my equation by 4. I'm going to multiply both sides by v. So just like I did 4 up top, -4, which now I'm right. Now I've got 4 on the brain. I'm going to multiply both sides of my equation by v. So now this becomes v times d is equal to, this becomes 1, so just m. We've solved for m. Our goal, our equation variable that we wanted, is by itself. Our two terms that we multiplied, our products, are on the left side. We're done. We're good to go. We have solved it. Now this is an important, the reason that we want this is because I can solve this for any one of these. If I want to know what, this is density is equal to mass divided by volume. So if I wanted to say what volume, if I wanted volume, I would do the same step, but then I would take it one step further. I'm going to solve this equation for volume. I'm going to divide both sides by dv. Now, oh, sorry, not dv. I'm going to divide it by d. Because d, I'm going to divide both sides by d. Now that becomes 1. And so volume would be equal to mass divided by density. So you're just dividing it by that variable that we want to go away. Okay, it's that simple. I will see you in the next video where I will talk about the other problems. See you then.